Hey guys, it's Miss Johnson, and I am here to bring you our first notes video for Unit 6. Today we're talking about Unit 6, Notes 1, which is on exponential functions. So our learning target is I can graph and interpret exponential functions. First, let's just talk about what is an exponential function. We've spent a lot of time talking about linear functions. We've also talked about quadratic functions. We know linear functions make a line, quadratic functions make a parabola, and that parabola could even either open up or down. But what do exponential functions look like and what do they do? So the exponential base function or the standard function looks like this. It's y equals a times b to the x power. B cannot be 1 and b has to be greater than 0. So b is going to be positive no matter what way you look at it, but b could also be between 0 and 1 and greater than 1, just not equal to 1. Okay, so now here's the thing that makes this exponential. The thing that makes this equation exponential is the fact that x is an exponent. And that is what gives us an exponential function. When we had linear functions, we had y equals mx plus b. X was just down in the variable position. Quadratic functions, we had y equals ax squared plus bx plus c. We had a power, but the power was 2. Here, our power is x. That's what makes functions exponential, okay? So the other thing that's nice to know about these exponential functions is that a is your starting amount, a is your starting amount or value or whatever you want to call it. So, but this is the key. This is the important one. That's what makes a function exponential. Okay, so let's just talk about what these things look like. We're going to take some time to graph them. In number one, we have y is equal to 4 to the x power. Now, on your tables, we're going to set up a table and graph these. On your tables, I'm going to fill in my x values the same way every single time. I'm going to do -2, -1, 0, 1, 2, 3. Now, I realize that the tables that were printed for you don't have enough rows. Just add that 3 on the bottom. That's just going to be an extra row right underneath. You'll have plenty of space for it. So now my x values are going to be the same every single time I try to graph one of these things. So then what I need to do is figure out the y values. So I'm going to plug it in. I've got y is equal to 4 to the -2nd power. So plug that into your calculator and you'll find that you get 0.0625. Then I need y is equal to 4 to the -1st power, and I get 0.25. I need y is equal to 4 to the 0 power, and I get 1, because anything raised to the 0 power is 1. Y is equal to 4 to the 1st power, that's 4. Y equals 4 squared, that's 16. And y is equal to 4 to the 3rd, that's going to give me 64. Now you're probably noticing or realizing already that this is going to be a really heavy calculator unit. Calculating all of these powers is not very easy to do by hand. It's really convenient and important for you to have a calculator. So if you didn't have your calculator out yet while working on this lesson, you might want to go ahead and get it out now. So let's talk about what this graph looks like. So over here at -2, it's at the very edge of your coordinate plane. -2, I'm at 0.0625, barely, barely, barely above the x-axis. And then -1, I'm at 0.25, still very, very close to the x-axis. Then when I get to 0, I'm up here at 1. 1, I'm at 4. 2, 16. There's my 15, there's my 16, I'm over at 2. And then 3 is 64, and that's going to go really high off your coordinate plane. So here's kind of a picture of what these graphs look like. It's going really, really flat, and then all of a sudden it turns and increases very dramatically, very quickly. So I didn't draw that graph very pretty, but if I were to draw it a little bit nicer, it's going to get a curve kind of like that. It is also possible for you to have exponential graphs that curve down, and we'll see some of those as well. So that's what you see when you look at an exponential graph. You're going to look for that curve. Okay, so you've got that curved line. It is not a straight line connecting those. It is a curved line. Let's take a look at y equals 3 to the x in number 2. So again, my x values are always going to be the same. I'm always going to go -2, -1, 0, 1, 2, and 3. So then I go ahead and plug all of those in. Y is equal to 3 to the negative second power, and I get 1/9 or 0.1 repeating. Some of your calculators may tell you that as a fraction is 1/9. So then y equals 3 to the negative first was 1/3 or 0.3 repeating. Remember that that line over the top of a number is called a repetition. It just means that that number repeats forever and ever and ever. Y equals 3 to the 0 power. 3 to the 0 power is going to be 1. Y equals 3 to the first, that's going to be 3. Y equals 3 squared, that's going to be 9. And the last one, y equals 3 to the third, that's going to be 27. So now putting that on the coordinate plane, -2, I'm very, very close to the x-axis again. -1, I'm at a third above the x-axis. Then 0, I'm at 1. And that helps. 1, I'm at 3. 2, 9. And 3 is going to be 27, which is significantly off your coordinate plane, somewhere up there. But that just gives you a picture of how this graph is going to increase dramatically. So it's kind of like that. Notice, by the way, that my exponential function curves out and goes flat. It's hard to see because we're only going out to -2, but your curve really is flat, 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 really, really close to the x-axis, and then all of a sudden dramatically curves up. So it actually never crosses the x-axis. It's always going to stay above it. It's going to get closer and closer and closer and closer to the x-axis, but it's never going to go down and cross it. So that's just one important thing. One thing I forgot to talk about in the last question, sorry about that, the y-intercept. If we go back to number 1 and take a look at the y-intercept, your y-intercept is always where x equals 0. So it's right here, your y-intercept is 1. And again, in this question where x equals 0, your y-intercept is 1. So I know that that's where that graph is crossing the y-axis. Let's try number 3. In number 3, I've got y is equal to 4 times 2 to the x power. So I'm going to, again, number my values the same way. -2, -1, 0, 1, 2, and 3, that one that's going to go right off your table a little bit. Then I got to plug them in. So y is equal to 4 times 2 to the negative second power. Y equals 4 times 2 to the negative first power. Y equals 4 times 2 to the 0 power. Y equals 4 times 2 to the, 2 to the first power. Y equals 4 times 2 to the second. And y equals 4 times 2 to the third. So that's what all my equations look like. And then when I go ahead and plug all of those in, y equals 4 times 2 to the negative second power should give me 1. Be very careful here. The only thing that's raised to the negative second power is the 2. So if you want to be really careful on your calculators, you need to put that 2 in parentheses. Okay, you need to put that 2 in parentheses. So literally I would type in 4 and then my times button and then parenthesis, then 2, then close my parenthesis, then caret key, then -2. That's how I would type that in there. Okay, and you should get 1 for a value. If you're not doing 1, or if you're not getting 1, then your calculator might be doing something a little different. You need to be careful that you do not multiply these together first, because the 4 is not being taken to the power, only the 2 is. So you kind of have like a little cutoff there. That's being raised to the negative second, then I multiply. So I've got 1, then when I plug the next one in, I get 2, the next one gives me 4, the next one gives me 8, the next one gives me 16, and 32. So my y-intercept, I can see already, is right here where x is equal to 0. My y-intercept is 4. And then if I put these on the coordinate plane, -2, I go up to 1, -1, I go up to 2, 0, I go up to 4, 1, I go up to 8, and 216 up here, and then 3 is 32, and it's a little bit off your coordinate plane. So my graph is going to kind of taper out down where I can't see it yet. And there we go, it curves up like that. Now I just want to talk about this equation for a second before we move on. So take a look at these values. If you notice, going from 1 to 2, I doubled. 2 to 4, doubled. 4 to 8, doubled or multiplied by 2. 8 to 16, multiplied by 2. 16 to 32, multiplied by 2. That comes from this b value here. This value is like your growth or decay rate. So that's where all of those changes are happening. Then the other thing I want you to take note of is the fact that your y-intercept here kind of matches your a value. Now that's going to change if we have anything behind it. We could be adding or subtracting something behind it, but we're not in this case. So then our y-intercept ends up just being that a value. That's no coincidence. That does actually mean something in this case. All right, let's go ahead and talk about number 4. In number 4, we are looking at y equals 6 times a third to the x power. So I want you to go ahead and fill in the x values. You've got -2, -1, 0, 1, 2, 3, and then pause the video right now and see if you can fill in the y values on your own. Okay, so these are my y values that I came up with. If you take a look at that table there. Notice now that my y values seem to be decreasing. So at -2, I'm up at 54, which is way off my coordinate plane. But then at -1, I'm at 18, right about there. And then 0 down here at 6. Then 1 down here at 2. 2, I'm at 2/3. And then 3, I'm at 2/9, which is really close to that x-axis. You can see now that your graph is decaying. It's going down, or in other words, what we call exponential decay. And then it's going to turn, and like I said, it's going to be kind of flat with that x-axis. It never crosses the x-axis. It's just going to go really close and close and close and closer and closer. My y-intercept is still 6. But let's take a look at our equation. With that growth rate here, or I guess in this case I should say decay rate, this 1/3 value is less than 1. Since that value is less than 1, my graph now is decaying instead of growing or increasing. It's decreasing or going down. So that's what happened to my y values there. It gives me that decay graph or that curve that's going the other direction, and that's what we have. I'm going to go ahead and stop our video here for now. We'll finish up your other video. We'll watch the rest of it in class tomorrow. Don't forget to bring some headphones with you and hop back to Schoology and take that quiz. Thanks for listening. Have a great night.